So now that we've talked about the overall Java parallel image StreamGang structure and purpose, let's talk about its structure and functionality in more detail. And we're going to talk about the integration of object-oriented and functional programming paradigms. We've talked about what these are. A paradigm is just a fancy way of saying criteria for classifying things into one bin versus another. So for example, with object-oriented programming, we typically have concepts and features like abstraction, inheritance, polymorphism. For functional programming, we have other concepts and features. So we might talk about lambda expressions or method references, or if you're more into pure functional programming, monads and currying and so on. So with each of those paradigms comes certain collections of things that are important. And one of the key things I want to get across to you is a hybrid language like Java is cool because it combines object-oriented and functional programming paradigms together into one nice, tasty salad or enchilada or whatever the combination might be. We're also going to talk about some of the patterns we covered before as we go through this stuff to pull all the pieces together and give you a way to look at the overall structure of the solution and make sense of it, because again, it's got a lot of pieces. So here's a UML class diagram for a portion of the ImageStreamGang app design. And this, of course, is focusing on the object-oriented aspects, because object-oriented programming relies on things like classes, which are abstractions, extension, which is inheritance, and virtual methods, which is polymorphism. So if you take a look at this, this is a high-level class diagram. We left out a lot of the details, but it shows some of the cool stuff involved here. So these classes together provide the capability of downloading and processing images. But that's not necessarily very useful to look at it just that way, because it doesn't give you a guide for knowing which classes do which groups of things. So at the heart of this overall program is something called the StreamGang framework, which is a framework for initiating streams that process input from a list of URLs. Remember what a framework is. A framework is an integrated collection of software components, classes, objects, functions, etc., that collaborate together to provide a reusable architecture for a family of related applications. What the heck does that mean? Well, we have an integrated set of classes, kind of the things we're seeing here. They work together. There's going to be lots of interactions and dependencies and things, dispatching stuff. And they provide a reusable architecture. This architecture could be applied to other things beyond just image processing. And they give you essentially a reusable application that can be customized. So this is a reusable application that can have pieces added and removed in all kinds of clever ways. That's what a framework is. And the framework is involved in initiating processing streams that are functional to process the images from a list of elements. So the StreamGang framework doesn't know that it's dealing with images. It just knows that it's dealing with stuff. And that's the purpose of a framework, to be generic. And it uses some of those cool Gang of 4 patterns like template method, and it uses factory method in order to be able to keep it very flexible and extensible. We then create an ImageStreamGang, which is a customization or an extension of StreamGang that knows about downloading and processing images, whereas StreamGang doesn't know anything about that. It knows about how to get input and how to dole out the work, but the ImageStreamGang customizes that. So it's one level more refined. And then we've got a bunch of customizations of that. These are basically, again, inherited subclasses that inherit from ImageStreamGang and then do the various capabilities that provide us with different ways of running the program, either sequentially, in parallel, reactively, asynchronously, and so on and so forth. So it probably wouldn't surprise you that ImageStreamGang, or ImageStream Sequential, is the sequential version of this stuff. So it uses a sequential stream to download and filter images sequentially. The ImageStream Parallel, surprise, surprise, uses parallel streams to download and filter the images in parallel. And then we've got other stuff which uses completable futures, and there's a couple different variants of that. And then we're going to have reactive streams. I couldn't even fit it all in one slide. But the point is that the interactions between these various elements in the software architecture are well thought out, and they build on each other. So once you understand the basic concept of a StreamGang, then you understand ImageStreamGang is a customization of that. And then we further refine that ImageStreamGang for different types of concurrency and parallelism and asynchrony and reactive programming models. There's also, of course, things we're doing the work upon, which are the images. So we have an image class that stores metadata about each image and provides methods for being able to do common image and file-related activities, like transforming it in an abstract sense. And then we have this other hierarchy, which is the filter hierarchy, that applies operations to filter and store the images. So this is what's going to be actually doing the transformation. And this particular grouping here uses the decorator pattern. And in fact, if you look here, you can see we have names of classes with filter decorator. And so it's going to allow us to reuse a lot of the overall structure of keeping track of images and then be able to apply decorators to them to customize them without having to change the base portions that know how to just deal with the images as an image, as opposed to a transformed image. So once again, we've got all kinds of cool patterns here. We've got the template method pattern, which is used extensively because we have a base class with certain abstract hook methods that then get customized by subclasses, and then we use decorators and other kinds of things as well. For the Android version of this app, then we have another set of classes that deal with interacting with the user interface. So the key abstractions in Android are these things called activities. And so we have activities that are used to interact with the user, to prompt them to give the images and the image URLs they want. And then we also have another activity that displays the results. For the console version of this, for the quote command line version, there's a different set of classes because we don't have to worry about a fancy GUI. It just basically reads stuff from a command line and then does the work and stores it locally on the file system and prints the results out on the console. So something else I want to point out, this is really interesting, and this is, again, just a tiny snippet of the bigger picture here. But because we have all these different implementations, we have the parallel streams and the sequential streams and the completable future version. We also have a version that uses reactive streams and various flavors and so on. We can actually do very nice apples-to-apples comparisons between the different strategies. And we can see the results. And so here's one set of results. And this was run on my Lenovo laptop, which has 8 hyper-threaded cores, so it's 16 virtual cores, and 128 gigabytes of RAM. Kind of interesting, by the way, the Apple MacBooks still don't seem to go beyond 64 megabytes of RAM. I don't know why they don't go more, but the Lenovo give you just an enormous amount of RAM, double, in fact. And when I ran the tests, you'll see that there are 2 different tests. One is testing downloading and transforming and storing large images, and the other is downloading, processing, and storing much smaller images. And what happens here is kind of interesting. For the larger images, the sequential stream, of course, is the laggard, because it's only going to be using one thread. Parallel streams are substantially faster, basically a factor of 3x faster. And interestingly enough, the completable future versions are substantially faster than parallel streams for large images. And we'll talk a bit about that when we get to the completable futures part of the class. But in a nutshell, completable futures are a little harder to program, but as you can see here, sometimes that pays off because they can get better performance. Ironically, for smaller images, again, the sequential stream stuff was a laggard as usual because it's only using one thread, but parallel streams actually did quite well. Now, when you start talking about 62 milliseconds versus 68 milliseconds, that is in rounding error range, and so chances are they're probably about the same. But the point of all this is that once you've got a framework that's programmed in a systematic way, you can conduct these tests and get results that are probably fairly accurate if you warm up your thread pools correctly. So that's an end of the quick overview of the structure and functionality of the ImageStreamGang, looking at it from the point of view of software architecture and design.